Fine. Uh, Today we'll discuss about a few disadvantages of LVM as well as how to overcome these disadvantages of LVM in Linux administration. Okay. The point is in LVM here we have one scenario. Let me tell you that I have one few disks like this: SDB, SDC, SDT. Now we have clubbed these three disks here and we have created one volume group VG, and from this volume group we have created one LVM logical volume. Into this volume we are writing the data. Into this logical volume we are writing the data. So when you write the data in this logical volume, the data goes to volume group. From volume group it gets divided into these three disks. Okay, so when you're writing the data into this logical volume, as the data is written into multiple disks, the read rate speed is always normal. Read rate speed is normal. And one more thing, if any one of the disk is crashed here, then what happens? The data of that particular disk will be lost. That means if a disk is crashed, there's loss of data. So we have these two disadvantages. Read rate speed is normal, as well as if a disk is crashed, we cannot recover the data. So if you want to have recover, if you want to overcome these two options here, then we can implement a configuration called write, which is called as redundant array of independent disk, where array is called as redundant array of independent disk. When you talk about these writes here, we'll be having two different types of writes. One is called as a software write, write, and second one is called as a hardware write. Okay, software write means the write that we implement by using an application software is called a software write. Means the package comes with operating system. With that we can create a write. It's called a software write. Hardware write is every some few advanced servers comes with the inbuilt hardware controllers. So with the help of these hardware controllers, when you try to configure a write on the servers here, that is called as a hardware write. So we can configure two different types of writes here. One is called as software write and second one is called as hardware write. I'll be showing you today that how to configure the software write. Okay. So what this write is and what is the advantages and all this we'll discuss one by one. Now, for example, see, and one more thing, especially when you talk about these rights here, categories of rights, we have different categories of rights here. One is called as concatenation. Second one is called as striping. Third one is called as mirroring, and fourth one is called as striping with parity. Striping with parity. So we have these four different categories of rights. And when you talk about its run levels here, we have different run levels over here. So what the run levels are? For this concatenation, we called as write 0. So this concatenation comes under this category called write 0. And under striping here, we called as this concatenating called as, this is also called as write 0. And mirroring comes under write 1. And striping with parity, this is called as write 6. Especially we have different kinds of configurations also here, like write 0 plus 1. 0 plus 1. What is 0 means? It can be either concatenation or striping. What is 1 means? Mirroring. So what is 0 plus 1 means? This combination of these two. 0 plus 1 can be either concatenation plus mirroring or striping plus mirroring. Striping plus mirroring, like this. So 0 plus 1 means concatenation plus mirroring or striping plus mirroring. Or otherwise, they even do like this one, write 1 plus 0. So what is 1 plus 0 means? This is nothing but first mirroring will happen and then concatenation will occur, right? Or first mirroring will happen along with this striping will occur, like this. But the thing is, in your Linux operating system, it supports up to only these levels. that is concatenation, striping, mirroring, striping, mirroring, striping, parity. These levels are not supported in this Linux. If you want to have a support of this, so we need to go for a next level of software that is called as VXVM, which is called as Veritas Volume Manager. So in this Veritas Volume Manager, we can configure these things, but not into this Linux operating system. As of now, for the clarification, we need to know what is this concatenation means, what is striping means, what is mirroring means, and what striping with parity means. Just remember this letters here. This is 5. Striping with parity means rate 5. Mirroring means rate 1. So under rate 0, we have two combinations. What are they? Either concatenation or striping. And Linux doesn't support this concatenation. So rate 0 means in Linux we call it as striping. Rate 0 in Linux means striping. So what is the difference between these two? We'll discuss. Now, suppose here, see this figure, like in this figure here, the first thing is concatenation. In this concatenation, I'm using two disks of both of 10 GB and 10 GB. Assume that my first disk, this is like SDB, and the second disk is SDC, SDB and SDC, each of 10 GB, each of 10 GB. So what I'll do, I will club these two disks. If you want to configure right here, we need to club these two disks and create a meta device. A meta device is called as a logical device. So if you club these two and create this meta device, a logical device, so what the size of my logical device will be? The size of my logical device will be 20 GB, right? Why? Because I'm adding two disks here, and the size of each disk is 10 GB. So 10 plus 10, the meta device size is 20 GB, right? Now, so what we'll do is when you go for this in LVM concept here, in LVM concept, what we have done, we have clubbed these two disks and create a volume group, and we have formatted a logical volume. We created a volume group, and volume group we have created a logical volume, and on this logical volume we have written the data. Okay. So firstly, what we have done initially in file system, we have this disk SDA. In this disk, we have created partitions SDA S7, like SDA 8 and SDA 9. We have formatted these partitions and written data on these partitions. Whereas in LVM here, what we have done, we have clubbed these disks and created one volume group. Like as per yesterday's conversation, my data VG, my volume group, and created one volume. What my volume name is my LVM. So what is my full path here is, my full path is like this, /dev/ my volume group name is my data VG, and my volume is my LVM. So we have formatted this path. Now today, when configuring a RAID configurations, yeah, when you create a meta device, we'll give some number, right? So what the numbers can be like this MD0, or like your MD1 or MD2, like this we can configure up to 128 devices. How many? 128 devices. And these 128 devices can be from MD0 to MD127. So like this, we can create 0 to 128, that is 128 devices, where 128 RAID configurations you can configure in one system. Okay. Now, so as per our example, in this example here, I'm using two disks here. What are the two disks are? One is SDB. What the size of SDB is? 10 GB. And second one is SDC. The size is 10 GB. So we are clubbing these two disks and we'll create one meta device called MD0. So what my size of MD0 will be? 20 GB. Now, if you want to format this, how do you format /dev/ like MD0? This is the device name. Okay. Now, so in concatenation, when you club these two disks, if you want to do concatenation means two or more disks. So clubbing two or more is called concatenation. Now, in this example, I'm using only two disks. What the two disks are? Two SDB and SDC. So if you want to do concatenation, we require minimum two disks. and maximum you can connect up to 32 disks. In concatenation, we require, if you want to configure concatenation, we require minimum 2 disks and we can connect up to a maximum of 32 disks. Okay. So the configuration can be any number from MD0 to MD127. This can be from MD 0 to 127. Now, when you format this MD0 and write some data to this MD0, so what happens? The data initially falls into first disk. The data writes into first disk. What the disk is? SDB. Sorry, this is SDB. Into this, the data is written in sequential format. What are they? A, B, C, D, E, F, G, H. It writes the data into first disk. When the first disk is completely filled up, then what happens? It automatically goes to the second disk. You can see after G, it goes to like this one, H, I, J, K, L, M. This numbers is for like identification purpose only. Remember, if you want to do concatenation, we require minimum 2 disks and we can connect up to a maximum of 32 disks. Okay. So in concatenation, when you write the data into the meta device here, so how the data is written? The data is written sequentially, means it first writes the data into first disk. When the first disk is filled up, then it automatically goes to the second disk. Okay. Now in this configuration, what the thing is, the read rate speed is normal. What the read rate speed is normal. It's as usual. Why? Because we have one header. The header is writing the data into first disk. When the disk is filled up, it automatically goes to the second disk. But what is the advantage here is, the advantage is we are able to write into multiple disks. We are able to write it into multiple disks. But one thing is, suppose if something is happened and this disk is gone, SDC, suppose this disk is crashed, then what happens? The data is lost. We cannot recover. The thing is, a fault tolerance is not available. So what is the advantage is, we are able to write the data into 2 disks, means after filling the first disk, it automatically goes to the second disk. That is only one advantage. Reader speed is also normal and fault tolerance is also not available. This is concatenation. Okay. Now let's go for striping here. So when you go for striping, in this striping also, I've been using 2 disks. The 2 disks are the first disk. Assume that the first disk is like your STB, and the second disk is SDC. So if you want to do this striping, we require minimum 2 disks. 2 disks are mandatory, and maximum we can connect up to 32 disks. Can connect up to maximum of 32 disks. So when you club these 2 disks and create one meta device here, the meta device size will be 20 GB. The meta device size is 20 GB. Now into this meta device, in striping configuration, when you write the data into this meta device, so how the data is written means, the data is written alternatively and evenly. How the data is written? Alternatively and evenly, means you can see it, observe carefully. So first some data is written into disk A, then it goes to the second disk and write some data, come back, write some data, and go back, write some data. Here 2 headers are activated simultaneously, means 2 headers will be activated simultaneously. The 2 headers will be writing. So initially it writes some data into one disk, means initially it writes 32 bytes of data, and when it keeps on writing 32 bytes of data, it goes to second disk and initializes 32 bytes of data, come back, write initialize 32 bytes of data, go back, initialize 32 bytes of data. So it writes the data alternatively and evenly, in which the 2 headers will comes into the active field. So what happens means, because of this configuration, the read rate speed becomes faster. Read rate speed becomes faster. In this concatenation, only one header is active. After filling the first disk only, we are going to the second disk. After filling the first disk, only going to the second disk, read write speed is normal. But here we are able to write the data into two disks alternatively and evenly. So two headers will be activated, because of which the reader speed becomes faster. This is one of the default configuration in your Linux operating system. So one advantage is, we have two advantages here. We are able to write into two disks simultaneously. And as we are writing the data alternatively and evenly into two disks, the read write speed becomes faster. Then what are the disadvantages are? Disadvantages is, for suppose if this disk is crashed, if the disk is crashed, then what happens? The particular data is lost. Means fault tolerance is not available. Fault tolerance is not available. If any one of the disk is crashed, the data is lost. Okay. In this concatenation, we have achieved only one point. What a point is, we are able to write the data multiple disks. In striping, we are able to achieve 2 points. What the 2 points is, we are able to write the data multiple disks and read write speed is faster. But in these two, one common configuration is fault tolerance is not available. Fault tolerance is not available. So I want fault tolerance. So what do you do? Then we can go for this configuration that is called as mirroring. Called as mirroring. In this mirroring here, I can connect. We mandatory that we require two disks, and the disk should be of equal size. So what happens if we use a different size? No problem. Suppose one disk is 10 GB, other disk is 100 GB. In the second disk, it uses only 10 GB. Other 90 GB goes waste. Because of that, it is said to use only like a equal size of disks. So I have two disks, SDB, and this is SDC. Okay. So in this mirroring, I have two disks, SDB and SDC. When you club these two disks, you can create a meta device here. Here, the meta device size will be 10 GB only. See this? In concatenation and striping, it's a combined value 10 plus 10, 20, 10 plus 10, 20. But when you come to this mirroring here, 10 and 10, but the meta device size will be 10 GB only. Why only 10 GB means, here in the mirroring here, what happens means the data is written simultaneously into two disks. The data is written simultaneously into two disks. You can see it here. When you write some data into meta device, C A, B B, C D D. So the data is written simultaneously and equally into all the disks. Okay. This is called as mirroring. So what are the advantages are? What are the advantages are in this? We are able to write the data multiple disks. Disadvantages is read write speed is normal. You cannot not say normal, it's somewhat slower. But the thing is, we have fault tolerance. What is fault tolerance means? Suppose if this disk is there, if the disk is crashed, no problem. I have the data in other disk. I have the data in other disk. So the thing is fault tolerance. So we have fault tolerance is mirroring. So especially in the companies here, what happens means in every server, initially they use two disks. They club these two disks in hardware write and will create one meta device. On this device, an operating system will be installed. On this device, an operating system will be installed. So when you install an operating system on this device here, so the operating system is installed into how many devices? Two devices. Okay. So if one device is gone, crash, no problem. I have the operating system in another device. I can use it from there. If both are gone, we cannot do anything, but we have one redundancy. So mirroring is very much important in the company. Why? Because it's by default configured in each and every server. Especially for the operating system disks, we'll configure mirroring and we'll install the operating system in that mirroring itself. Okay. What are the disadvantages are? Read write speed is slower. Okay. But what are the advantages? Fault tolerance. If any one disk is crashed, then we can overcome this. Now if you have here we have an advantage in this striping. What the advantage is? Read rate speed is faster. We are able to write into multiple disks, but no fault tolerance. Here, read rate speed is slower. Okay, but what the advantage is? Fault tolerance. We have fault tolerance. One disk is crashed, we can recover from other disk. So if you want to overcome these two disadvantages, one disadvantage is striping, one disadvantage mirroring, these club together and created this configuration. This is called as RAID 5, striping with parity. What is called as striping with parity. So for this striping with RAID 5, striping with parity, RAID 5 striping with parity here. For this, we require minimum 3 disks. We require minimum 3 disks, and all the disks should be of equal size. Assume that here I have used 3 disks, and the disk is like a SDB, and this is like SDC, and this is like a SDT. 3 disks. What the size of each disk is? 10 GB, 10 GB, and 10 GB. So when you club these 3 disks and create one meta device size is 20 GB. Why 20 GB? What about the remaining 10 GB? So what happened to the remaining 10 GB means in every disk here, in every disk, some space is allocated for parity. Oh, the text right? Yeah. Okay, like this. In every disk, at the top we have data, and at the bottom we have parity. Okay, one formula will be used. What is that formula and how do you use that formula? I will explain you clearly on this RAID 5 striping with parity. Okay, let us come to this. For this formula, to how the RAID 5 striping parity works, we need to have one. We need to remember this binary addition. In binary additions, we have this for 1 plus 0 is equal to 0 plus 1. 0 plus 1 is equal to, then 0 plus 0 is equal to. So in binary additions, we have this formula where 1 plus 1 is nothing but 0. 0 plus 1, oh sorry, 1 plus 0 is 1. 0 plus 1 is 1. 0 plus 0 is 0. In first one, like 1 plus 1, most of people think that it is 1, but it's not 1. That result is 0, and we have 1 as the addition here, the parity that will be added to the next bit. So this is the general formula we use in binary. Okay, just remember this. 1 plus 1 is 0. 0 plus 1 plus 0 is 1. 0 plus 1 is 1, and this 0 plus 0 is equal to 0. Okay. Now see this. I have 3 disks. A, B, and C. Okay. Now see here on the disk A, I'll write some data like 1, and disk B like 1. Disk again disk B like 1, 0, like 0, 1, 0, 0, like 1, 0, 0, 1, like this. So assume that on the disk A, data is A and B, the data is written, and the parity written on third disk, that is disk C. So what the parity is nothing but binary addition of these two values. So 1 plus 1, according to a formula, what the result is? 0. 1 plus 0, 1. 0 plus 1, 1. 0 plus 0, 0, 1 plus 0, 1, 0 plus 1, 1. So on disk A, assume that on disk A we have data, and on disk B we have parity. Okay. Now let us do one thing. Let us do one thing here. The disk, assume that disk B is crashed. Let me write the data of disk B here. 1, 0, 1, 0, 0, 1. Assume that the disk B is crashed. Okay. So when the disk B is crashed here, then what happens? We'll unplug that disk B and insert a new disk. When you insert a new disk here, so on the new disk there will not be any data. So when you insert a new disk to the system here, then what happens? It will recover the data with the help of parity. I have some data in disk A and I have parity in disk C. So from from this data from A and from parity from C, the data will be recovered. How? So like this one. Again, do the binary addition between A and C. 1 plus 0, 1. 1 plus 1, 0. 0 plus 1, 1. 0 plus 0, 0. 1 plus 1, 0. 0 plus 1, 1. If you go here, 101,001, they got the same data like this. So if any one of the disk is crashed here, then what happens? We can recover the data with the help of a parity, right? So especially the thing is, we have two disks here. The data can be written in two disks, or on the third disk we can write some parity. In general, that is what's done. But we can connect up to maximum of 34. Just a minute. Hello. Yeah, good morning. Yeah. Yes, please. Okay. Yeah, I'm available. Yeah. Yeah, anytime. 10 o'clock to 2 o'clock is not fine. Then schedule it for tomorrow. Anytime. Yeah, that's fine. Definitely. No, I will be available. Right. And the thing is, they are for the Pune location, but I'm looking something in Hyderabad. That's it. That's the only the destination is Hyderabad. Even though, for example, if a pandemic is done, if they come back, ask me to come back to Pune, my parents are not agreeing to send me back to like Pune anymore. You see it right now. We have something in opening in Hyderabad too. Then I'm sorry to say that if it's Chennai, Pune, and this one, I cannot. Okay, fine. No, right. Okay. Sure, definitely. Thank you. Right. నిన్నేమో హైదరాబాద్ అంటే ఈరోజేమో పూణే అంట. లొకేషన్కి వచ్చి పని చేయాలట. ఎక్కడ చేస్తారు? ఎవరు రెడీగా ఉండి మరి పోయి లొకేషన్ పోయి పని చేయడానికి. So rate 5, striping with parity. So we require 3 disks, and as per the explanation, so if parity disk is crashed, no problem, that will remove the disk and insert a new disk. Again, a resync will happen from this A and B. The parity will be recovered. Suppose if disk A is crashed, no problem, remove it and insert a new disk from B and C. The disk A will be recovered. Okay. So in this RAID 5 striping with parity, what are the advantages do you have is, we require minimum 3 disks when we can connect up to maximum 32 disks. We require minimum 3 disks and connect up to maximum 32 disks. The advantages are read rate speed is faster. You can see it here. The data is written A, B, C alternatively and evenly. The data is written alternatively and evenly. Okay, the data is written alternate and evenly. So when you write the data alternate and evenly, that means it is similar to striping. So what the advantage of striping is, read rate speed is faster. Read rate speed is faster. And if any one of the disk is crashed, no problem. We are able to recover. From where? From the parity, we are able to recover. So the thing is, fault tolerance is also available. Fault tolerance is also available. Now tell me that out of these four discussions here, so what the better one is? The better one will be RAID 5 striping with parity. Okay. So in the companies here and every server, we'll be having two configurations. We'll be using two configurations. For OS side, we'll be having mirroring. For OS side, for OS disks, they'll configure mirroring. And for data, they configure striping. Why? Because in striping, why? Because on data, we should be able to write the data, the reader speed to be fast should be faster. And if any one of the disk is crashed, when if you remove it and unplug it, we should be able to recover. Okay. So and recently in my company here, what happened means, especially general scenarios, if one disk will be crashed, so we'll try to recover the disk from the parity. We'll try to recover that from the parity easily. But what happened means the two disks are crashed. What happens? Two disks are crashed. So can you recover? We cannot recover. We cannot recover. If any one disk is crashed, we can recover. If two disks are crashed, we cannot recover. Again, what we'll do, we inserted a fresh new hard disk. We formatted everything. We created a meta device, and then we asked the backup team to provide the data. The backup team have provided. Then we have copied the data into this one. That is like a 12 terabyte of data, and to copy the 12 terabyte of data, it has taken 16 hours. And for these 16 hours, everyone was in the call. They are not allowed anyone to log off of the call until the entire data is recovered. They're able to start the application. They're able to access the data. And then they're given a green, yes, you can log off now. Okay. So you need to be very, very careful, and you need to be very clear with the concept. Very simple things. Concatenation, it allows the write into multiple disks, but the disadvantages is reader speed is normal and fault tolerance is not available. In striping, we are able to write it into multiple disks where the reader speed is faster, but the disadvantage is fault tolerance is not available. In mirroring, we can write the data into multiple disks. Reader speed is slower. Only advantages is fault tolerance is available. In RAID 5, striping with parity, we read rate speed is faster and fault tolerance is available. If any one of the disk is crashed, then we can recover it easily. So you need to be very clear with this one. So this is about these RAID configurations, and in the next session we'll be discussing about the practical implementation of this RAID 5. So what is this RAID 5, how to implement it? I'll show both mirroring as well as RAID 5 also. Okay. So you have 5 minutes now. If you have any questions, please let me know. Any questions and clarifications on these grade levels?
Hello.
Chapandi.
Can you configure 128 disk at one time, sir?
128 the thing is 128 configurations anamata. అంటే ఏంటంటే ఒక సర్వర్ లో మన 128 కాన్ఫిగర్, ఫర్ ఎగ్జాంపుల్ నా దగ్గర సర్వర్ లో 30 డిస్క్స్ ఉన్నాయి అనుకోండి. ఓకే, ఫస్ట్ ఒక రెండు డిస్క్లు యూజ్ చేసి ఒక మెటా డివైస్ MD0 అని కాన్ఫిగర్ చేశా. ఓకే, అంటే 32 డిస్క్ లో 2 డిస్క్లు అయిపోయి MD0 కాన్ఫిగరేషన్ అదేంటి నిర్వహించి చేశా. అట్లా MD0 అని చెప్పేసి ఇంకొక నెక్స్ట్ కాన్ఫిగరేషన్ వచ్చేసి MD1 అంటే మళ్ళీ డిస్క్లు కావాలి. మళ్ళీ డిస్క్లు కావాలంటే ఏంటి, మళ్ళీ డిస్క్లు కావాలనుకుంటే దానికి ఎక్స్ట్రా డిస్క్లు వాడనమాట. అంటే డిస్క్లు మనం ఎన్నెన్నో యూజ్ చేసుకోవచ్చు. కాకపోతే ఏ కాన్ఫిగరేషన్ కైనా ఒక MD0 అనే కాన్ఫిగరేషన్ చేసుకుంటే ఒక MD0 అనే కాన్ఫిగరేషన్ MD అనే కాన్ఫిగరేషన్ లో మాక్సిమం మనం 32 డిస్క్స్ మాత్రమే కనెక్ట్ చేయొచ్చు అనమాట. రైట్. అలా కాకుండా ఒక సర్వర్ లో మనం ఎన్ని డిస్క్ అయినా కనెక్ట్ చేసుకోవచ్చు. ఫర్ ఎగ్జాంపుల్ నా సర్వర్ లో వచ్చేసి ఒక 500 డిస్క్ కనెక్ట్ చేశాను.
ఓకే సార్.
ఒక ఎండి కాన్ఫిగరేషన్ కి ఒక ఎండి కాన్ఫిగరేషన్ కి 32 డిస్క్ యాడ్ చేయొచ్చు.
అవును.
అంటే
ఓకే సార్.
32 అని యాడ్ చేసుకుంటే 500 డివైడెడ్ బై 32 చేసుకుంటే ఎన్ని కాన్ఫిగరేషన్స్ వస్తాయో మీరు అన్ని కాన్ఫిగరేషన్స్ చేసుకోవచ్చు.
ఓకే. ఓకే.
అట్లాగా కొడతా ఉంటే ప్రాక్టీస్ చేస్తుంటే అప్పుడు క్వశ్చన్స్ వస్తాయి అన్నమాట.
ఓకే సార్. మెటా డేటా కాన్ఫిగరేషన్ సార్ డిఫరెంట్ సైజ్ ఆల్సో కెన్.
ఇప్పుడు ఏంటంటే మెటా డేటా అనేది ఆటోమేటిక్ గా తీసేసుకుంటుంది అనమాట మీరు ఇచ్చే రేట్ కాన్ఫిగరేషన్.
డిఫరెంట్ డిస్క్ సైజ్ ఆల్సో. ఒక
అట్లా
డిస్క్ 10 GB, 1 GB, 20 GB అలా
తీసుకోవచ్చు. ఇప్పుడు మెటా డివైస్ ఏం చేస్తుందంటే మీరు ఫర్ ఎగ్జాంపుల్ ఇక్కడ మిర్రరింగ్ తీసుకోండి. మిర్రరింగ్ లో ఎస్డిఏ వచ్చేసి 10 GB, లైక్ ఎస్డిసి వచ్చేసి మీకు 100 GB ఉంది అనుకోండి. ఈ రెండు డిస్క్లు కలిపి మీరు మెటా డివైస్ కాన్ఫిగర్ చేశారు అనుకోండి, అప్పుడు మెటా డివైస్ సైజ్ ఎంత తీసుకొని 10 GB తీసుకుంటది.
ఓకే. ఓవరాల్ ఏదైతే స్మాల్ అవుతుంది
ఫస్ట్ డిస్క్ లో 10 GB ఉంది కాబట్టి ఫస్ట్ డిస్క్ లో 10 GB రాయగలి కాబట్టి సెకండ్ డిస్క్ లో కూడా 10 GB తీసుకుంటది. కానీ మన 90 GB వేస్ట్ అయిపోతుంది అనమాట. మీరు ఎక్స్ట్రా సైజ్ డిస్క్ పెట్టొచ్చు కాకపోతే తీసుకోవాలి. ఒకవేళ తీసుకొని రాసేసింది అనుకోండి అప్పుడు మిర్రరింగ్ అవ్వదు కదా. అది
మిర్రరింగ్ అవ్వదు సార్.
మిర్రరింగ్ అవ్వదు కదా, అది అనమాట. సో ఈక్వల్ సైజ్ రికమెండ్ చేస్తారు అనమాట. అది ఇంపార్టెంట్ పాయింట్. ఒకసారి అడుగుతారు 10 GB 20 GB కనెక్ట్ చేయొచ్చు అంటే కనెక్ట్ చేసుకోండి, ప్రాబ్లం లేదు, కాకపోతే రిమైనింగ్ 10 GB వేస్టేజ్ పోతుంది. రికమెండేషన్ ఏంటంటే ఈక్వల్ సైజ్ ఆఫ్ ద డిస్క్ ఉంటే మంచిది అని చెప్పి చెప్పుకోవచ్చు అన్నమాట.
ఓకే సార్, అర్థమైంది. థ్యాంక్ యూ సార్.
రైట్, ఫైన్. ఎనీమోర్? Okay then, we'll stop it here for today, and